The Subcommittee on Space and Aeronautics will come to order. Good morning. Welcome to today's hearing entitled Exploring Mars and Beyond, What's Next for the U.S. Planetary Science. In front of you are packets containing the written testimony, biographies, and truth and testimony disclosures for today's witness panel. At this time, I'll recognize myself for 5 minutes for an opening statement. Today's hearing has been called to examine the future course of NASA's Planetary Sciences program, looking particularly at NASA's plans to carry out recommendations put forward in the Decadal survey released earlier this spring by the National Academy of Sciences. Before getting started, however, I'd like to thank our witnesses for agreeing to testify today. I realize a lot of work and effort goes into preparing for your appearance, and I want you to know that your wisdom and experience will be of immense value to this committee and Congress in the months and years ahead as we strive to maintain a vital national space program. In March of this year, the National Academy of Sciences published Visions and Voyages for Planetary Science in the decade 2013 to 2022. This report reflects a broad consensus of the planetary science community, first by identifying key questions that guide NASA in the decade ahead as it endeavors to develop the next series of missions, and then by providing NASA the tools needed to maintain a balanced and vital program that looks broadly across our solar system. It is the product of an immense effort that sought a wide range of input, including papers, meetings, and reviews by a committee chaired by Dr. Stephen Squyres. Unfortunately, budget forecasts provided by NASA to the Academy proved to be optimistic. To its credit, the survey committee had the foresight to anticipate budget shortfalls and included in their recommendations steps that the agency should follow to align programs with resources, all the while maintaining balance across a set of missions. For fairly obvious reasons, exploration of Mars has become the largest component of NASA's planetary science program, as well as one of its most visible. Through development of critical technologies, NASA has orbited the planet with powerful satellites, put rovers on its surface, and in less than 2 weeks' time is preparing to launch yet another rover that will be bigger and more capable still. The conundrum now facing NASA is selecting a mission that is the next logical step in our exploration of Mars and how to pay for it. The Decadal survey selected as its top priority mission as Mars sample cache and rover that would, in effect, be the first of a three-phase mission to return Mars soil samples to Earth. This will be a very expensive undertaking, and one obvious option would be to engage with the European Space Agency on a collaborative mission, thus reducing costs to the U.S. In November 2009, NASA Administrator Bolden and ESA Director General Dordan signed a joint statement of intent that spelled out a series of steps for the exploration of Mars that both agencies, working collaboratively, hope to pursue. Quoting from the statement, NASA and ESA agree to consider the establishment of a new joint initiative, define and implement their scientific, programmatic, and technological goals for the exploration of Mars. Initially focusing on 2016 and 2018, this initiative would span several launch opportunities with landers and orbiters conducting astrobiological, geological, geophysical, climatological, and other high-priority investigations and aiming at returning samples from Mars in the mid-2020s. So the question is, are we ready to make that commitment? Will NASA be a reliable partner, able to sustain obligations that span years, administrations, and unpredictable budgets? If not resolved quickly, I am deeply worried that NASA will be viewed by our international partners as an unreliable, schizophrenic agency. On the one hand, NASA is actively seeking international partners to collaborate on future missions. On the other, the administration appears to be interfering with the agency's efforts to reach out and engage foreign governments in future flagship missions. If these internal conflicts aren't soon resolved, NASA could be left alone to fly its own missions with budgets that will result in fewer flight opportunities. Meanwhile, other international space agencies will collaborate, and in time, they may well be able to fly space missions that were once the domain of NASA. Adding further uncertainties are NASA's struggles with the James Webb Space Telescope. To its credit, NASA identified offsets across the Science Mission Directorate, including planetary science, but did it in a way that did not undermine its ability to proceed with a descoped Mars sample cache and rover. Unfortunately, the White House has not yet approved the plan for release, preventing NASA from living up to its commitments to ESA and frustrating our European partners. Adding further insult, the White House won't even reveal what offsets will be taken out of planetary science's FY12 budget, suggesting that they'll wait until next February with the FY13 budget request rollout to identify offsets in the FY12 operating plan. I can't begin to make sense of the rationale for such a delay. Before closing, I also want to stress the importance of maintaining balance in the planetary science portfolio, both in terms of mission size and destination. NASA must ensure that flagship missions don't overwhelm the planetary science budget, as well as preserve a regular cadence of small to medium-sized missions. I realize my statement has covered a lot of territory, but in today's environment, discussing future planetary sciences missions necessarily involves agency budgets, international partners, the planetary science community, and the James Webb Space Telescope. I want to point out that the Office of Management and Budget was invited to testify at this hearing, but chose not to appear. I am not surprised, but I find it regrettable. OMB has enormous influence over NASA, as their decisions in many ways define the agency's future roles and missions. It would have been helpful to gain their perspective in these discussions. I now recognize our ranking member, Ms. Edwards, for her opening statement.
Thank you very much, Chairman Palazzo, and thank you for holding the hearing today to receive testimony on the prospects for future exploration of Mars and the implications of the current fiscal environment on the future of U.S. planetary science. Over the past 15 years, NASA has carried out a systematic exploration of Mars using orbiting spacecraft, landers, and rovers. These missions have resulted in dramatic changes in our understanding of the planet, its potential to harbor life, and our ability to eventually carry out human exploration of Mars. They've also established the United States as the undisputed leader in Mars exploration. The United States is the only nation in the world that's capable of successfully landing and operating a spacecraft on Mars. Our Mars exploration program has been a scientific success story. It's the envy of the world, and it's inspired countless young people to pursue education and careers in science and technology. What we don't know is whether or how that story of success will continue, and especially whether the United States will retain its leadership role. While the Mars Science Laboratory rover Curiosity is set to launch in less than 2 weeks, the future of the U.S. Mars exploration program is quite unclear. Given the extreme difficult fiscal challenges facing our nation, international collaboration, as recommended by the National Academy of Sciences Planetary Science Decadal Survey, would seem to be a sensible path forward that would allow the U.S. to sustain systematic exploration and pursue the top priority large mission, Mars sample return. Indeed, the President's national space policy also calls for such international collaborations in space activities. Building on their long-standing international partnership in space science, NASA and ESA, the European Space Agency, planned a joint initiative to collaborate on a series of future Mars missions. However, the status of that initiative now appears to be in question. In order to keep the vitally important James Webb Space Telescope on track, NASA will need to find an additional $1.2 billion over the next 5 years from within its science and agency operations budget. Decisions on how those science budget offsets will be made have significant implications for the future of the Mars program. Reportedly, OMB officials are overruling the scientific experts at NASA on how those offsets should be best allocated across the agency's science programs, with the result that NASA's long-planned joint NASA-ESA Mars program appears to be in serious jeopardy. If these reports are accurate, such action by OMB is a serious cause for concern, and I, too, would like to hear from OMB about that. This subcommittee needs to find out whether these reports are accurate, and if they are not, we need to find out what's holding up NASA's plans to move forward with ESA. I certainly want to make sure that NASA works vigorously to make sure that costs are kept under control as the agency embarks on the joint Mars program. Strategies to instill cost discipline on expensive missions can certainly be put into place, and we must be careful to avoid short-sighted bureaucratic decisions and end up dismantling a highly successful program and skilled workforce, jeopardizing U.S. leadership and retreating from a carefully constructed international partnership. The results of ill-conceived decisions, bureaucratic decisions, cannot be easily recovered at some later date, and we have to place a priority, I think, on the science. So I hope to hear from each of our witnesses today on the following. Has NASA's science program developed a credible plan to accommodate the cost growth of James Webb that will enable NASA to pursue the long-planned joint Mars initiative with the European Space Agency? What's preventing NASA from being able to move forward and commit to the partnership on the 2016 and 2018 joint Mars mission? And what's needed to get things moving? What's at stake if the United States doesn't commit to moving forward with ESA on Mars? I look forward to hearing the responses to these questions and others from the testimony of our witnesses today. And I thank you for being here, and thank you, Mr. Chairman, for your indulgence with my tardiness.
Thank you, Ms. Edwards. At this time, I will yield to the chairman of the Science, Space, and Technology Committee for a brief opening statement. Mr. Hall.
Thank you, Mr. Palazzo, and thank you for calling this hearing to examine NASA's planetary science program. I can't think of a more exciting and successful robotic space program that's electrified so many of our people, young and old, with images and discoveries about the solar system in which we live. The Mars Exploration Rovers, the Cassini mission that's still returning incredible data and pictures from Saturn, the Galileo mission that orbited Jupiter, and to me, one of the most notable achievements of the Voyager satellites that were launched in 1977 and still operating today, and are the farthest man-made objects lofted from Earth. There's so many other remarkable missions I didn't name, but the point is that NASA's planetary science program has accomplished so very much and has helped stake NASA's claim as one of the world's leading science and exploration institutions. And it's important that we work together to maintain this string of exciting missions for the next generation to enjoy the wonderment of science. There is, of course, a business side to attend to during today's hearing, and I don't mean to distract from that task, but I just want to thank our witnesses for being here and to urge NASA, the administration, the science community, and Congress to sustain this noble enterprise. I only wish they'd worked as hard at keeping the space station as they have in this program. I yield back.
Thank you, Mr. Chairman. If there are members who wish to submit additional opening statements, your statements will be added to the record at this point. Before proceeding with the introduction of witnesses, I would like to ask unanimous consent to enter into the record written statements submitted by the Planetary Society, the European Space Agency, and by Dr. Mark Sykes, CEO and Director of the Planetary Science Institute. Hear no objection, so ordered. At this time, I would like to introduce our witness panel. Our first witness is Dr. Jim Greene, Director of Planetary Science Division at NASA. Dr. Greene began his career at NASA's Marshall Space Flight Center in 1980. In 1985, he transferred to the Goddard Space Flight Center, where he served as Chief of the Space Science Data Operations Office, as well as Chief of the Science Proposal Support Office. He also served as a co-investigator and deputy project scientist on the IMAGE mission. In August 2006, Dr. Greene was named Director of the Planetary Science Division. Dr. Greene received his Ph.D. in space physics at the University of Iowa. Welcome, Dr. Greene. Our second witness is Dr. Stephen Squyres, the Goldwin Smith Professor of Astronomy at Cornell University. Dr. Squyres received his Ph.D. from Cornell in 1981 and spent 5 years working at Ames Research Center before returning to his alma mater as a faculty member. Dr. Squyres has participated in many of NASA's planetary missions, including the Voyager mission to Jupiter and Saturn, the Magellan mission to Venus, and most recently as principal investigator for the science payload on the Mars Exploration Rover project. Dr. Squyres served as chair of the Planetary DeKadel Survey for the National Research Council, and within just the last 2 weeks was named as chair of the NASA Advisory Committee. Dr. Squyres, thank you for joining us today. As our witnesses should know, spoken testimony is limited to 5 minutes each, after which the members of Congress will have 5 minutes each to ask questions. I now recognize our first witness, Dr. Jim Greene, Planetary Science Division Director of the Science Mission Directorate at NASA.
Okay, got it. Mr. Chairman and members of the subcommittee, thank you for the opportunity to appear before you today to testify concerning the NASA's planetary science program, our plans to implement the National Academy of Sciences Planetary Decadal Survey, and our joint Mars exploration program with the European Space Agency, or ESA. We are in the midst of what we call at NASA and our planetary science community call the year of the solar system. This current 670-day period, it's a Mars year after all, is chock full of astounding scientific results and amazing accomplishments of many of our planetary missions to a wide variety of bodies throughout the solar system. My written testimony summarizes these for you. In my brief few minutes here, I will only say that the capstone of the Year of the Solar System activity is the launch and landing of the Mars Science Laboratory and its rover Curiosity on the surface of Mars. MSL now sits on top of its launch vehicle, awaiting its launch window opening on November 25th. And for me, Thanksgiving will occur after a successful launch. Looking to the future, NASA is committed to the National Academy of Sciences Planetary Decadal Survey in planning the future of our planetary science program. We take the Planetary Science Decadal Survey very seriously because it represents a broad national science community consensus. The Planetary Science Decadal assures the progress on our highest priority science questions and keeps NASA and the planetary science community focused on these objectives. The survey recommends NASA conduct a balanced mix of missions: Discovery, New Frontier, and Flagship missions. The survey's highest priority flagship mission is a Mars 2018 rover and sample caching mission as a first step in a Mars science sample return campaign. It can only be done, as the Decadal survey states, if NASA is able to reduce the cost to less than $2.5 billion. The survey further recognizes the need for a Mars 16 and 18 missions to proceed together. And the survey recognizes that NASA must move forward with these, only with ESA, to accomplish these missions. NASA has been studying approaches to return samples from Mars to Earth for well over a decade, and now the science community is ready and eager for us to get started, as delineated in the new Planetary Science Decadal. Since 2007, NASA and ESA have been planning the Mars sample return concepts together. The joint effort led to a 2009 statement of intent signed by the NASA Administrator and Director General of ESA on a joint Mars robotic exploration program. And this includes Mars 2016 and 2018 missions. We are working extensively with ESA since the 2009 agreement to define a program to accomplish these missions within the available budget. The results of this effort must be ready soon if we are to make the 2016 launch window and to enable the NASA-ESA partnership to move forward. The Decadal Survey's second priority flagship is a Jupiter-Europa mission. This orbiter, as the Decadal Survey recognizes, or JEO, Jupiter-Europa Orbiter, would cost approximately $4.7 billion, far more than the available budget for a planetary flagship mission. And so, the Decadal recommends to NASA to undertake a redefined JEO mission at a cost that would minimize the size of the budget necessary to be increased to enable this mission. That JEO mission concept study is well underway and should be completed late next spring. The survey's third priority flagship mission is a Uranus orbiter and probe, and rounding out the list are an Enceladus orbiter and a Venus climate orbiter. Currently, NASA is working to define an approach with ESA to implement the highest priority flagship. Overall, we are working to define a flagship mission that can be implemented in this decade in the context of a balanced mix of mission sizes and classes recommended by the Decadal. I would like to take this opportunity now to publicly thank Dr. Steve Squyres for his leadership of the Academy Committee that produced the Planetary Decadal Survey. It is providing us a tremendous valuable guide in planning our future planetary science portfolio as we knew it would be. Thank you for the opportunity to appear before this committee today, and I am pleased to answer any questions you may have.
Thank you, Dr. Greene. I now recognize our next witness, Dr. Steve Squyres, Chair of the Committee on the Planetary Science Decadal Survey for the National Academies of Science. Dr. Squyres.
Thank you. Mr. Chairman, members of the subcommittee, thank you very much for the opportunity to appear here today. The National Research Council's DeKadel recommendations to NASA covered many topics. These include the Planetary Research and Analysis Program, technology development, small discovery missions, and medium-sized New Frontiers missions. In all of these areas, the agency's response so far has been to follow the NRC recommendations closely. The one area to date where NASA has not followed NRC recommendations has been the implementation of large flagship missions. Flagship missions are vital to the health of planetary science. And as stressed in the NRC DeKadel report, flagship missions are an essential part of a balanced program of exploration. A program made up of only small and medium-class missions would be unable to address the most challenging and important issues in planetary science. The DeKadel report did not state that flagship missions have lower priority than other smaller missions. It stated that an appropriate response to a declining budget is to delay or descope flagship missions, which is a very different thing. The NRC report provided a prioritized list of planetary flagship missions with clear decision rules for choosing among them. The highest priority flagship mission recommended by the NRC is a Mars sample collection and caching mission to be conducted jointly with ESA, the European Space Agency. This mission would collect a well-chosen suite of samples for return to Earth at a later date. Sample return is the crucial next step in Mars exploration and is the best way of addressing the question of whether life ever took hold on Mars. The mission would also conduct significant new science on the Martian surface. Other high-priority flagship missions discussed in the report included a mission to investigate a probable subsurface ocean of liquid water on Jupiter's moon Europa and an orbiter probe mission to the ice giant planet Uranus. Now, as the spectacularly successful Cassini-Huygens missions to Saturn and Titan has shown, international partnerships can be enabling for flagship missions. The NRC report concluded that partnership with ESA is essential for the Mars sample caching mission and for the Mars program overall. The same may also be true for other high-priority flagships as well. ESA can bring substantial capabilities and resources to a partnership, lessening both the risk and the financial burden to NASA. In my view, the publicly available budget guidelines that have been provided to NASA by the Office of Management and Budget are sufficient as they stand to allow the agency to enter into a partnership with ESA and to carry out the program recommended by the NRC. To date, however, the administration has not committed to this partnership. If no such commitment to a flagship mission is made, the result will be highly detrimental to the future of U.S. planetary science. Speaking more pragmatically, I fear that an inability to enter into a mutually beneficial partnership with a willing, eager, and highly capable agency like ESA may jeopardize future international partnerships as well. Three other points are noteworthy regarding the recommended Mars mission specifically. First, NASA's current concept is substantially descoped from the original one, exactly in line with the DeKadel recommendation to descope flagship missions in the face of declining budgets. Second, the current concept makes extensive use of existing hardware designs, reducing cost risk. Third, the remaining missions in the sample return campaign can be carried out over an extended period of time, if necessary, spreading the costs out in time as well. Finally, I would like to stress a critical point. The ability to carry out the most challenging tasks in deep space exploration, tasks like landing and roving on Mars or orbiting Europa, is one of our nation's great scientific and technical crown jewels. If we give up that capability by abandoning planetary flagship missions, then we do a disservice not just to ourselves, but also to future generations of American scientists, engineers, and explorers. So in my view, it is essential that NASA maintain this unique capability. The resources to do it within a balanced program are available. What's needed is the willingness to commit these resources to this essential task. Thank you.
Thank you, Dr. Squires. I thank the panel for their testimony, reminding members that committee rules limit questioning to 5 minutes. The chair will, at this point, open the round of questions. The chair recognizes himself for 5 minutes. Dr. Greene, how does restructuring the James Webb Space Telescope program and the increased funds needed to complete the program affect NASA's Planetary Science Division? Will there be programs canceled as well?
The administration has stated clearly that James Webb is a priority and that the funding for James Webb in the future, based on its shortfall in the existing budget, based on the President's 2012 submission to Congress, would be handled in a 50-50 arrangement between the Science Mission Directorate and other elements within NASA. In addition to that, OMB has been working with the Science Mission Directorate to determine the process and procedure to identify those funds. And once that has been completed, and it is not, it will be delivered to Congress in February when the President delivers his 2013 budget.
How are you executing the programs in the Planetary Science Division, knowing that there will be likely cuts to those programs nearly halfway through next year, or the current fiscal year?
Mm-hmm. Well, currently, as we create, through our partnership with ESA and discussions on how to implement 16 and Mars 2016 and the Mars 2018 mission, we've entered those discussions knowing that there may be changes or possibly changes in our current budget profile. So we have a considerable interaction with ESA. We have not made commitments that would, by the administration, commit them to that set of missions. And so we've done so in good faith that by the time the President has determined his priorities, delivered his budget to Congress in February, our path forward will be clear.
Dr. Squires, there's a widely held perception that NASA is no longer in charge of developing its programs and is instead being directed by the OMB on which programs to pursue. What is the danger to U.S. scientific leadership and to the scientific community as a whole if this is indeed the case? And does this undermine the legitimate work of the DeKadel survey process?
The danger to planetary science in the United States is severe, if that is the case. As I stressed in my opening remarks, flagship missions are an essential part of a balanced program of exploration. We rely on flagship missions to do the most important science. And if we are not able to implement those missions, then our leadership in areas like answering fundamental questions like, was there ever life on Mars? Is there life on Europa? These really important questions is going to be, I won't say challenged, it's going to go away. We're going to lose a fundamental capability. And moreover, not only do we lose the science, but we cannot simply give up that technical capability, the ability that we have to do things like orbiting Europa or landing and roving on Mars. That's something that we know how to do in this nation. And if we give that capability up, the people who know how to do that, they're going to go off to other jobs. They're going to do other things. These are smart people who are in demand, and you simply cannot reconstruct that instantly. So I feel that the danger is severe, both to the science that we've identified in the NRC report now, but also to our prospects for being able to do similar science in the future.
Why do you say NASA is no longer working toward flagship missions?
I'm perplexed, sir. I sense within the agency a strong desire to do flagship missions, and my reason for saying that is that I know that in response to the NRC's report, NASA has totally restructured the partnership with ESA for the Mars mission to make it much more affordable within budget guidelines. They have done exactly as Jim Greene said, and they have found ways they're working on ways to dramatically decrease the size and cost and complexity of the Europa mission. So the studies are going forward. The designs of the missions are being revamped so that the DeKadel recommendations can be followed, and yet there's no commitment being made. I'm perplexed.
Dr. Greene, would you like to comment?
Yes, I would. Of course, we all know our roles and responsibilities within the federal government. OMB, its role, of course, is one of developing a budget with OSTPs, use of the President's priorities, and then implementing that through interactions with the agencies and moving forward. My role within the federal government is to advocate for planetary science. I am the top official for the advocate for planetary science as we move forward. We recognize in this environment of difficult budget situation that we're in that compromises have to be made, decisions have to be executed that are based on the administration's priority. Currently, OMB has not officially notified NASA of canceling Mars 16 or 18. And so those discussions are ongoing. We meet with OMB on a regular basis. They know the details of our studies. We've worked with them quite intimately, and of course we're eagerly awaiting what the ultimate priorities will be and whether we'll be able to proceed with the Mars 16 and 18 mission as our partnership with ESA has delineated.
Thank you. I now recognize our ranking member, Ms. Edwards from Maryland.
Thank you, Mr. Chairman, and thank you to both of our witnesses. And Dr. Greene, I have to tell you, when I hear your testimony and I see you, what I see is a person of science who has a real enthusiasm for the work that you're doing. It radiates. And so you've given me that energy too, and so thank you. I want to get kind of right to it. First of all, Dr. Greene, did OMB review the testimony that you're giving to this subcommittee today?
Yes, OMB, as our normal procedure, does review our written testimony.
And did they have to approve it before you could submit it to the subcommittee?
Yes, that is the normal process.
And Dr. Greene, Dr. Squyres testified that the National Academies has deemed the joint NASA-ESA Mars sample collection and caching mission to be the highest priority flagship mission in planetary science. And I appreciate Dr. Squyres' testimony about the importance of balance within the mission directorate. Yet, according to Dr. Squyres, and I quote, "To date, however, the administration is not committed to this partnership." Is Dr. Squyres correct in saying that the administration has not yet committed to the NASA-ESA mission?
As I mentioned earlier, we have not been notified by OMB that Mars 16 or 18 has been canceled. Therefore, our approach is to continue to work with ESA, continue to find ways to lower our costs, and meet both of the objectives from the European Space Agency and for NASA.
But have you gotten an explicit commitment from the administration on the NASA-ESA partnership?
Based on the fact that OMB has not canceled officially the 16 and 18 mission, which is part of our statement of intent that General Bolden, Administrator Bolden, and Director General Dordan signed in 2009, we're proceeding on good faith in our connections with ESA and continuing to plan this mission.
But not because you've gotten an explicit commitment from the administration?
We believe that because we have a signed agreement, a statement of intent to proceed on these studies, that we will continue to do so.
Dr. Squyres, do you believe that that there is an explicit commitment on behalf of the administration for the NASA-ESA mission?
I have had the opportunity. I've had the opportunity to engage in conversation with individuals at the Office of Management and Budget, and in those conversations, I have been told the administration is at this current time not ready to make such a commitment.
Okay, and so, Dr. Greene, does NASA want to do the mission?
NASA does want to do this mission.
Does ESA want to do the mission?
ESA does want to do this mission, and in fact, we need each other more than ever before. Let me comment and take this time to talk a little bit about that relationship because it's extremely important to understand. In the past, our connections with a European partner or another agency have always been who leads the mission and one mission at a time. Mm-hmm. The particular effort that we're engaging with ESA is for a series of missions. And instead of a small contribution, it's a major contribution on each other's part. So this is a long-term partnership that is we're moving forward with, and we have the agreement by Director General Dordan of ESA and Administrator Bolden to continue aggressively to pursue our programs. So indeed, NASA is fully behind the 2016 and 2018 mission.
So let me just be clear. The scientists at NASA want to do the mission.
Yes.
At ESA, they want to do the mission.
Yes.
Congress hasn't prohibited it.
Yes.
So who's blocking the two agencies from moving forward?
As I had mentioned earlier, OMB takes their job seriously of looking throughout the federal government for opportunities to overall lower the costs to this nation, the taxpayers, and consequently, they're using a system of priorities to be able to look at these programs, decide which will move forward and which will be canceled.
You know what, Dr. Greene, I don't want to put you in the position of having to answer that question. What I want to know, and it would be helpful to hear from OMB directly about why things are being held up and who's holding them up, given that the two agencies that would be principally responsible for moving this forward, at the recommendation in the DeKadel survey, as we've heard from Dr. Squyres, why we're sitting in a holding pattern. And so I look forward to hearing from OMB about that. And Dr. Squyres, just as I finish here, I just want to be clear. Is there anybody in particular at OMB who told you about the administration's willingness or unwillingness to commit to the partnership with ESA?
Yes, it was a meeting with Sally Ericsson.
Thank you.
I now recognize the gentleman from Texas, Mr. Smith.
Thank you, Mr. Chairman. Dr. Greene and Dr. Squyres, in the last 20 years or so, the search for extraterrestrial intelligence has become, I think, a serious academic and scientific subject. Do you feel that the National Academies of Science how do you think that they feel about the likelihood of micro-life being found in our own solar system? And Dr. Greene, let's start with you and then go to Dr. Squyres.
One of the aspects of planetary science is in the area of astrobiology, and that is to do that, what we have been doing is looking at, does life live in extreme places on this planet? And in many of these extreme places, we do find life.
Actually, you're anticipating my next question, but let me go back to that first one again. National Academies of Science, do they think there is a strong likelihood of life being found in our solar system?
The National Academy, through the Planetary DeKadel, has a major undercurrent of astrobiology science that's in it. It is indeed all about looking at regions in the solar system with the potential of habitability, okay, and with the potential of life. So yes, indeed it does.
Good. And now my next question that you anticipated, again to ask both of you, and actually Dr. Squyres mentioned a while ago the possibility of life being found on Mars or Europa. And right before this hearing today, you were saying to me that if we just find a thimbleful of water, that's very likely that that's going to contain some form of life. So do you think, or do you want to say today that it's almost certain that we will find micro-life on Mars and Europa? Dr. Squyres. Okay.
Sir, I learned a long time ago, about 8 years when we first landed our rovers on Mars, not to predict
I know where you're going, and therefore give me a percentage of likelihood.
You know, if I could do that, sir, I would be so.
If you say 100%, you'll make a lot of news today.
Yeah, no, I would be thrilled. What I'd like to say is that it is no coincidence that the two highest priority planetary flagship missions recommended were to Mars and Europa. What sets those worlds apart is their potential life. And it is the judgment of the National Academy of Sciences and National Research Council that the probability is high enough that there could be life on those worlds or could have been life on those worlds, that it is worth investing the resources in those flagship missions to find out.
Dr. Greene, let me use a legal term. Is it more likely than not we will find life on Mars and Europa, or one or the other, if you think it's more likely on one?
I simply don't know, and that's the nature of science, sir.
Okay, Dr. Greene.
I would agree with everything Steve said, that's for sure.
You're not going to bite it more likely than not?
If we don't have the opportunity to look, we'll never know.
Okay, fair enough. Let me, on my next question to both, actually, Dr. Greene, I'm going to pass on you. I don't want to put you on the spot either, but let me direct my next question to Dr. Squyres, and it's a follow-up to the chairman's question a while ago about OMB. OMB is clearly saying that they feel there's not enough money for all the planetary missions. And clearly they are, I think, picking and choosing what they consider to be the administration's priorities. My question, Dr. Squyres, is this. Do you think the administration's priorities are the general consensus priorities of the scientific community?
The general
and if not, where do they differ?
The general consensus priorities of the science community are, I believe, those expressed in the DeKadel report. So to the extent that the administration's position differs, then it differs from the scientific consensus.
Okay, and what would be examples of that?
Examples of that would be an unwillingness to commit to these high-priority flagship missions, despite the fact that NASA has labored heroically, and I believe successfully, to bring their costs into the affordable range, indeed into the range of budget projections that have been provided publicly by OMB. So it's a little bit perplexing when you see OMB's budget projections, which, by the way, are declining precipitously for planetary exploration, which is another issue for this committee to consider. But even given that, the missions that NASA has now restructured in response to the Decadal survey fit within the projected budget profiles, and yet the agency has not been given the opportunity to move forward with those anyway.
Okay. Thank you, Dr. Squyres. Thank you, Dr. Greene. Thank you, Mr. Chairman.
Ms. Fudge, I understand you don't have any questions at this time?
That's correct.
Okay. All right. And so at this time, the chair recognizes Mr. Rayburn from California.
Thank you very much, Mr. Chairman. Dr. Greene, what was the original budget estimates that we approved of for the James Webb Telescope?
Because that's not in my direct field, nor am I involved in any of the budget determinations of James Webb, I will have to get back to you on that.
Mr. Squires, do you know that?
No, sir, I do not.
Okay, let me remind you, it was $1.6 billion. And I suppose you don't know how much today we're being asked to complete the program.
I believe the James Webb Group has completed their initial or their review of replan and have provided to Congress that cost estimate.
Right, that's $8.8 billion. I would suggest to you there is a relationship between that cost overrun and the other cost overrun that we have to deal with here in Congress and the success of America's space programs. Would you agree with that?
Well, what I try to do within the Planetary Science Division is to articulate our goals and our priorities,
right,
and let the administration determine its overall priority within the nation.
I would suggest that the people of NASA decide to get involved when certain elements of their operation and other people within the space program are doing things that are detrimental to the long-term interest of a well-funded and effective space program. If there's anything that is a greater danger, I mean, I would say that cost overrides and of this nature are certainly a greater threat to a viable space program than the asteroid belt or anything else that you would face up there that God has presented as an obstacle for us to moving forward into space. This is outrageous. Let me another area. So you have 1.6 billion from the originally from the James Webb Telescope. Now it's 8.8 billion. Would you think that perhaps the Space Launch System at $18 billion now, as an estimate, might go up with the same magnitude of an increase in cost? Well, I won't be burdening you both because obviously you don't know that. It's not your area. But Mr. Chairman, we need to put on notice, NASA and the rest of these people, these kind of cost overruns are killing the program. And I certainly appreciate the great words that you said, and I've been a supporter of the space exploration program. I think it is a gem, an incredible thing that we can brag about and be proud about as Americans. But we can't be proud about is this bureaucratic incompetence that's leading to such massive billion-dollar over expenditures that are coming right out of the heart of these programs. We've got to get serious about this, and if we're not, it's not, by the way, I don't believe it's congressional back and forth and indecision that's causing these things. I don't believe that. I believe we have honestly set forth some money for programs, and we come back all the time with cost overruns that kill our ability to do any other programs. Well, I hope that we can send our exploration missions to Mars and to Europa. I think you're right. That is a noble and a historic endeavor and should be led by the United States of America. We might end up having to do cooperation with our European friends or maybe even the Russians in order to accomplish this because of these damn cost overruns. Well, I would hope that we people realize you have a right to criticize other people within the American space program when they're doing these things that are going to end up with such a horrible outcome for all of us. Let me get back to, by the way, the Space Launch Program. Are any of these missions that we're talking about, landing these things on Mars, the rovers and the various Mars programs versus, I don't mean manned now, but and into Europa, except for a manned mission, is there some reason we need this, the mega rocket of all times, the space, they call it gigantic or what, so the space Titanic that we're building with this, which will have its own cost overruns as the iceberg in the way. Do we need that extra huge rocket to accomplish any of the missions you're talking about today?
Currently, the design of our 2016 and 18 missions in cooperation with ESA will use the EELVs, the expendable launch vehicles that we currently have under contract through the NLS-2 contract.
So if we end up with a cost overrun, which is now $18 billion, at the same level as the cost overrun as the James Webb Telescope, it'll suck up all the money from all these various programs, and we don't even need that rocket in order to accomplish the missions that you're telling us are so important today. I agree with you. Thank you very much.
I now recognize the gentleman from Alabama, Mr. Brooks.
Thank you, Mr. Chairman. Radioisotope power systems utilize heat converted from the nuclear decay of radioactive isotopes to generate electricity. RPSs, as they are commonly known, are frequently used to power spacecraft that travel large distances and in extreme environments. Yet the United States ended production of plutonium-238, the key nuclear component of RPSs, back in 1988. Despite no new production, its use continues. Most recently, the Mars Science Laboratory used about 3.5 kilograms for the multi-mission radioisotope thermoelectric generator, and the next Discovery mission has reserved 1.8 kilograms for 2 advanced Stirling radioisotope generators. The DeKadel survey indicates that in order to complete the recommended program, new plutonium-238 production is essential or more deliveries from Russia will be necessary. It concluded, and I quote, "The committee is alarmed at the status of plutonium-238 availability for planetary exploration. Without a restart of plutonium-238 production, it will be impossible for the United States or any other country to conduct certain important types of planetary missions after this decade." Mr. Greene, what programs are in jeopardy if production does not get underway for plutonium-238?
Mr. Brooks, as you know, Congress actually has been quite generous in allowing us to have the funding necessary to work with the Department of Energy to move forward in developing the plans necessary to restart the production of plutonium-238 that, as you point out so well, is vital to many of our missions in the future. We feel confident that as we move forward in this budgetary process and as our relationships with Department of Energy are quite excellent, that we will begin to do that development of the capability that then will generate the fuel necessary for the future. So I believe we're on the path to do that. And once again, I want to thank Congress for recognizing that and enabling us to facilitate that.
Well, the House Appropriations Subcommittee for Energy and Water denied funding for DOE for plutonium-238. But back to my question, what programs are in jeopardy if production does not get underway?
We do have a limited supply of plutonium-238 in the Department of Energy, and so consequently, That will be used for potential missions, such as you mentioned, our Discovery mission. We're using plutonium-238 for the Mars Science Laboratory right now. There's a lot of discussion based on what the 2018 mission will look like and where it needs to go, whether plutonium-238 would be needed for that. Our Discovery program and our New Horizons, or New Frontiers program, and many of its missions all require plutonium-238 to be able to be accomplished. So indeed, many of the missions throughout the planetary Decadal, and this is one of the reasons why they're recommending the ability to produce this vital material, will be in jeopardy if we're not able to do that by the end of this decade.
Thank you, Dr. Greene. Now, further, how long does it take from the instance we decide to restart production before we have available plutonium-238? Do you have a judgment on that?
We delivered a cost-sharing plan that also outlined some of the basic capabilities to Congress more than a year ago. And following that plan, let me just mention a couple aspects of it. Currently, our need for plutonium is such that existing capabilities within the Department of Energy can be utilized. This means that no new facilities have to be developed, but only a time-sharing of the current use of those facilities. So depending upon the environmental assessment impacts and other studies that need to be done to then delineate how we would move forward, production could begin within the next couple years.
In your judgment, when is the absolute deadline for production to begin before it starts adversely affecting some of our NASA missions?
If we stay on the timescale, as I mentioned, we should be okay.
Well, do you have a judgment as to what that time frame is? How long?
We would like to see the production of plutonium-238 begin within the next several years. Now, once that material is produced, there's quite a set of processes that have to kick in to be able to make that available for future missions. And so there is a long lead time that we have to be cognizant of.
And finally, do you have a judgment as to the cost to restart plutonium-238 production?
As delineated in that report, utilizing the existing facilities in the Department of Energy, that cost estimate is anywhere between $70 and perhaps $90 million.
Thank you, Dr. Greene.
Mr. Clark, welcome to the hearing. I understand you don't have any questions at this time. Okay. I now recognize the gentlewoman from Florida, Ms. Adams.
Thank you, Mr. Chair. Dr. Greene, there have been several reports in the media recently that NASA is considering abandoning the Flagship Mars sample catching mission due to specific direction from OMB. Do you believe Mars missions to study atmospheric as well as geophysical conditions are a crucial step for planning a human exploration mission to Mars, something for which SLS could be used?
Indeed, I believe that, as the National Academy has stated in other reports, sample return is absolutely vital before we provide missions and plan missions for humans to explore Mars.
Do you believe, could the United States send humans to Mars safely without this type of scientific inquiry beforehand?
Based on the Decadal survey and what we know about Mars, I do believe it's essential that we bring back samples.
So what role does the cost of launching these missions play into your budget profile? For example, would it be possible for NASA to build a satellite or a rover that you did not have the money to launch it on time?
I'm sorry, could you please restate that?
What role does the cost of launching these missions play into your budget profile? For example, would it be possible for NASA to build a satellite or a rover that you did not have the money to launch on time?
Indeed, before we can move forward with any mission, we have to be able to plan adequately for all aspects of the mission. So that's our best guess in terms of what it would cost to develop such a mission, along with its science instruments. But in addition to that, we also have to budget for a launch vehicle. And how we do that is we use the current contract that NASA has. It's called the NLS-2 contract. based on the mass of the spacecraft and other engineering aspects of that.
Just yes or no at this point, because I have some other questions.
Yes, we have to be able
Thank
to
you.
budget for the launch vehicle within our
Thank
budget
you.
wedge.
Dr. Squires, let's assume the administration does not allow the Mars partnership with ESA to move forward, and the ESA does the mission with Roscosmos. What would be the effect on American planetary science of European and Russian scientists having access to Martian soil and rock samples that Americans do not?
I think there are two detrimental effects. One, of course, is that science in this nation would suffer because we would no longer have the ability to do the cutting-edge science, because the cutting-edge science would require access to materials that we would not have. The other is that having lost the capability to fly such missions, we would be poorly positioned to develop other important science missions beyond that. So I think we'd lose two ways.
You state in your written testimony that you believe the publicly available budget guidelines given to NASA by OMB are sufficient to allow Mars sample collection if we partner with the ESA. If the budget profile is sufficient, the skill sets are available, and the partner is willing, what is stopping the mission from moving forward?
In my view, it has been the unwillingness to date of the administration to commit to that partnership.
And there is a widely held perception that NASA is no longer in charge of developing its missions, and it's instead being directed by OMB on which missions to pursue. What is the danger to U.S. scientific leadership and to the scientific community as a whole if this indeed is the case? Does this undermine the legitimate work of the Decadal survey process?
The Decadal survey was our best attempt as a community of planetary scientists to state priorities for space exploration. It was carried out at the request of NASA. We gave them our best considered advice as a community of literally thousands of planetary scientists. And it's important to us to either see that advice followed or to understand why it has not been.
And what is the danger to U.S. scientific leadership and the scientific community as a whole?
The danger to our leadership is that we could lose it, flat out. We have a capability as a nation to do deep space exploration that no other entity on this planet possesses. We're better at this than anybody. And I would like to see this nation maintain that capability, not just for the science of these missions, but for the utility that that capability has to conduct other missions in the future that we can't even conceive of at this time.
And just to be clear, Dr. Greene, you said that OMB is the President's priorities, basically, correct?
Well, the President...
Yes or no?
Yes.
Thank you. I will yield back.
At this time, we'll go into a second round of questions for any members that would like to ask additional questions. And I will go ahead and recognize myself first. Mr. Squires, or Dr. Squires, in your dealings with our international partners, most notably the European Space Agency, do you sense frustration with the U.S. or a growing unwillingness to partner with us in the future?
I hope, sir, that there's not a growing unwillingness. And no, I have not sensed a growing unwillingness. In fact, I have sensed exactly the opposite, that there is an enthusiasm to future partnerships. It has not been my perception in talking to my European colleagues that they have concluded yet that we are an unreliable partner. I sense enthusiasm. I do, sir, sense frustration.
What is the scientific rationale for a Mars sample return mission, and why is this deemed as the most important flagship mission for the coming decade?
I was hoping somebody would ask that. Mars sample return is, in the view of our community, the next logical step in Mars exploration. If you look at what we have accomplished at Mars in the last 15 to 20 years, we are now to the point where the most significant step forward can come from bringing samples back. The reason for that is that it's twofold. First of all, we have learned enough about Mars to know the kinds of places we must go to get the most important samples, so we're ready. The other thing, and this is coming from somebody who has devoted his career to building instruments and sending them to Mars is that the best science is always going to get done in laboratories on Earth. Okay, the kind of instrumentation that exists in laboratories on Earth far surpasses in its capability what you could ever hope to send to the Martian surface on a robotic vehicle. Moreover, it's important to recognize that return samples are, in a sense, a gift that keeps on giving. The very best science ever done with samples collected from the moon during the Apollo program 40-plus years ago is being done today by scientists who had not been born at the time those samples were collected, using instruments that had not been conceived of. So if you can bring samples back, they not only enable you to do cutting-edge science today, but they enable you to do it for potentially decades into the future.
I now recognize our ranking member, Ms. Fudge from Ohio.
Thank you, Mr. Chairman. Both of these questions will be to both or either, but preferably both. Thank you for coming. With the prospects of flat or reduced budgets for planetary sciences, NASA will be challenged to initiate expensive flagship missions while also maintaining a balanced program that includes small and medium-sized missions. To both of our panelists, our witnesses, what are the options for pursuing top priority flagship planetary missions, and how should Congress weigh in on those options?
For us to be able, in the planetary budget, which is declining, that the President submitted to Congress in February, indeed that is very challenging, and for us to be able to pull off the DeKadel recommendations of a balanced portfolio of small, medium, and large flagship missions, we have to be able to partner. And with ESA, we have found an outstanding partner. They have been fabulous throughout our entire connections and over the years, and we've done a number of major things together. And this partnership is very strong.
Cannot be right. Go ahead. Okay. Thank you.
The only thing that I would add to Dr. Greene's statement is that I would like personally to commend the agency on the work that they've done along these lines already. When we wrote the DeKadel report, we identified the need to dramatically reduce the scope, cost, and complexity of both the Mars and Europa missions, and NASA has already taken substantial strides forward in doing both of those.
Thank you. To what extent is NASA's robotic planetary science program an enabler for human exploration missions beyond low Earth orbit?
Okay. While humans are developing the capability to leave low Earth orbit, this is really the decade for planetary scientists. In other words, the President's agenda, for which he has a flexible path, a number of destinations, we're there discovering a variety of aspects of that phenomena, looking at the hazards, understanding what those environments are all about. That's absolutely essential. Human exploration is not Star Trek. It's not go where no man has gone before. It really involves detailed studies of a variety of objects that human exploration is planning to go to, such as back to the moon, asteroids, and of course Mars. So this is a perfect time for us to be able to really get down to business and do a tremendous amount of science in support of human exploration also.
Yeah, I'll just add that one of the things that we stressed in the DeKadel report was the way in which these missions to targets that are potential targets for human exploration can lay the groundwork for that. And this is something NASA has done since almost the beginning of the agency. I teach a course at Cornell about the history of exploration, and I was just talking to my class the other day about the way that the Apollo landings on the moon were preceded by the Ranger missions and the Surveyor missions and the Lunar Orbiter missions, and all of those missions laid the groundwork that was partially enabling for the success of Apollo. I think the same can happen at asteroids. I think the same can happen at Mars.
Thank you, gentlemen. Mr. Chairman, I yield back.
Seeing no other members with additional questions, we will bring this hearing to a close. I thank the witnesses for their valuable testimony and the members for their questions. The members of the subcommittee may have additional questions for the witnesses, and we will ask you to respond to those in writing. The record will remain open for 2 weeks for additional comments from members. The witnesses are excused, and this hearing is adjourned.
Thank you.
Thank you so much.
Okay.